Okay, let's take a look here at the quiz question. And that was 72, huh? 72, oh, you're getting nothing on the screen there, huh? 72x squared minus 32. Oops, let me try plugging you in again. There we go. All right, so so there's the quiz question. Factor that. So what's the first step?
What do they have in common?
Yeah, what do they have in common? What goes into 72 and 32? And if you look at the multiple choice options, that's always a good idea, to look down at the options, try to go, look, a couple of them have an 8 out front. Probably the 8, huh? Probably the 8. So let's go back and say, I bet it's 8. Let me put an 8 in front, and then just divide that guy by, not 6, but 8. Divide by 8, divide by 8. That'd be 9x squared, and that'd be 4. So far, so good? Mm-hmm. Now, what do we do with 9x squared minus 4? What kind of, we'll leave the 8 here. What is this? This is an FL, isn't it? Yeah. Because it's only 2 terms, right? If it was 3, we'd do FOIL, F-O-I-L, right? But with 2, we just do FL, which just means like it's the 2 parentheses, front times front to make front. What times what makes 9x squared?
3x and 3x.
3x and 3x. Right? And then last times last to make 4. 2 times 2. And how do you make a negative 4?
Negative and positive.
1 positive, 1 negative. Right? To make negative 4? Hey, but, and then that's it. That's the answer on that. Wasn't that the answer on the part A? Yeah, if we go back. Yeah, that was part A, right? Option A. Good. Well, it was good. I know it was good. 80-something% of you nailed it. Great. Good. The exam was pretty good. You guys are my top. I don't think I'm exaggerating. I think you are the highest scoring Math 201 class I have personally ever had. That's great. All right. So they're asking me to solve. Can you all read that okay? C squared plus 12c plus 32 equals 0. Now, pretend that equals wasn't there for a minute. Let me just get rid of that. That's what's new. I could have given you this as a quiz question today, or as a question on the last exam, couldn't I? So why don't you just do that real quick? Just go ahead and factor that thing. You know how to factor that thing.
No, I don't.
Right, with the 2 parentheses and everything. Just go ahead and do what the great majority of you already know how to do. Exactly. Right, so do the 2 parentheses, just like we've always been doing. Yeah, exactly right. We're looking for what multiplies to be the back number, right? Adds to be the middle. That's the FOIL. You can write FOIL if you prefer. It's the same thing, right? The last times the last. They multiply to be the back number. They add to be the middle number. And, what's going to go in the front of each parenthesis? Yeah, C and C, right? C times C is C squared. And then what times take, 32, use your calculator if you're rusty on some of those times tables. What times what's 32? 8 and 4, huh? And that does add to be 12, so that's all good. Okay, so that's what you already know, huh? That's not new at all. Okay, but now they're putting this equals 0 thing on there. That's what's new. So the only thing new about this section, it's going to be super simple if you're good at factoring. If you're good at what we've already done, which a great majority of you are, more than I've ever had before, then this is just going to be one more step.
You're going to set each of the parentheses equal to 0.
You know it. Yep, you take the first one equal, and just get rid of the parentheses. Yeah, you set them each equal to 0. So the new part is the equal 0. That's what's new in this section. So I'll write the new equal 0 is the new part. And what we do about that is we set each part equal to 0 and solve. Solve meaning get C alone. So I set each part equal to 0. Now, why do I set each part equal to 0? I'll come back to that in a minute. For now, let me just say you do. I want a logical reason for that. I'll come back to that in a minute. For now, let's just say you do. It goes from 1 equals 0 to 2 equals 0s. For who knows why. We'll come back to it in a minute. Now, how do I finish this? C wants to be alone here. What do I do to get C alone? minus the 8 from both sides. And C wants to be alone here also. What do I do? Minus the 4 from both sides. And the way those are answers. The way Math Excel wants you to type it in is both answers with a comma. The order doesn't matter. You could put the minus 4 first, then the minus 8, whatever, but just list them both with a comma. That's what they want. Those are the two answers that make the equation true. Either one of those makes the equation true. By the way, you could test it out and prove it's really true. You don't have to. It's not required at all. But if you go back up to the beginning there, if you put minus 8 back in the very first step, minus 8 squared plus 12 times minus 8 plus 32, will it really equal 0? It will. If you work that out, what is minus 8 squared? What's 8 squared?
64.
8 times 8?
64.
64. I'm just, you don't have to write this down. I'm just proving it's really an answer. That'd be 64. 8 times 12, 80, 90, minus 96. Use your calculator. Plus 32, if you work it out, it is 0. It's true. Minus 8 makes it true. And so does if you plugged in minus 4, that would work also. Anyway, not required. I'm just showing you. Those really are answers, meaning those are things, if you put them in, they would make the original equation true. Those are the two answers, minus 8 and minus 4, that solve or make true the original equation. Does that make sense? Questions I can answer on that. So the only new part with the equal 0 is you just set each one equal to 0 and solve. The rest is what you already, the beginning, all the factoring, you guys are already good at that. Now, why logically, like what's a good reason for setting, why do they both equal 0? How can it go from one of them equals 0 to 2 equals 0?
Equal to 0. So each
What
of
does that
the
mean?
things has to cancel out the equation equal to 0. Well, not cancel out, but.
Yeah, I know what you're saying. How about I put it, you're right. How about I put it in these words? What if I said, hey guys, I'm thinking of two numbers in my head. Okay, I am. I got two numbers in my head, and I bet you can guess one of my numbers. You ready? We're going to play guess one of Mr. Heron's numbers. I'm thinking of two numbers in my head, and I'm multiplying them together. I'm going to give you a clue about my numbers, about one of my numbers. I'm multiplying those numbers together in my head, one times the other, and it's coming out equal to 0. Number times number in my head, and it's coming out equal to 0. How do you multiply two things and get an answer of 0?
One has to be 0.
Doesn't one of them have to be 0?
Yes.
Right? Like the first one could be 0, and 0 times anything would be 0. Or the second one could be 0, because anything times 0 would be 0, huh? Right? If I'm one of my numbers is 0, huh? It's either the first one or it's the second one if they're timesing and becoming 0. Well, do you realize that he is saying you're multiplying one thing times another thing and it's equaling 0. Well, then that first thing is 0 or that second thing is 0. That's just reasonable. That's why. Right? If two things times to be 0, either the first one's 0 or the second one's 0. Either one could be 0 to make that happen. So that's it. That's the only new part. Shall we try and let's see. So there's number 2. So a squared plus 5a minus 14 equals, so the new part is the equal 0. So do the parentheses like we normally do. Everybody get the yellow and blue test? Everybody get the yellow and blue test? Be up here if you knew. So feel free to check with those around you. Do the two parentheses. Okay, so you're doing the multiply add thing, right? We got two parentheses. A times A in the front, right? What times what? What multiplies to be 14?
7 and 2.
Yeah, 7 times 2. Now, how do you do the signs? Do you remember the rule for the signs?
The first sign comes to the first hand.
Yeah, the sign in the middle goes on the
Bigger side.
bigger, which is the first one, yeah. Question? All good? Make sense on that? Everybody good with that? So that's a real important rule, right? The sign in the middle always goes on the bigger. 7 is bigger than 2, so the 7 gets the middle sign. All right, now what do we do from there? So now if they didn't have the equal 0, I would just stop, huh? That's what we did in the last section, the exam you just took. You just got back, right? Those were the kind where we would just stop, it's just done. But because this one has equal 0, we're not done. We have to go a little further. And logically, if two things are timesing, right, to be 0, the first one can be 0, or the second one can be 0. Either one can be 0 to make them multiply and equal 0, huh? And so then how do you solve that? Just subtract 7. So A is minus 7. Add 2. A is plus 2. In other words, it's always just going to be opposite sign of what it is in the parentheses, isn't it? So if you want to just jump from here right to that answer, here to the answer, that's fine. That's just what it's going to always do. It's always going to be the opposite sign. Right? That good? So the answers are negative 7 and regular 2. Either order. You can put the 2 first and the minus 7. Doesn't matter. Two answers with a comma. No parentheses or anything like that. We're not graphing or anything. Just like that. Good? Questions? Easy? Okay, so try that one. A squared minus 7a equals 0. Again, it's got the equal 0, right? So that's the new part. Okay, factor. Now, is this like the kind where you do the 2 parentheses?
No.
No, good. Is everybody good with that? Remember, when do you do the 2 parentheses? Well, that would be if we had 3 numbers, huh? Right? Well, better said, how about this? What's the first step in every factoring problem? What do they have in common, huh? Good. That's always the first thing. Before we dive into the 2 parentheses or the whatever, you want to say, hey, what do these guys both have in common? What do they both have the same? A. And do the 1 parenthesis. Remember that? Remember how we always do that first when they have something in common? And then say, okay, A times what? We'll go back to A squared. A. And A times what? We'll go back to minus 7a. Minus 7. Good to there so far? So this one's not the 2 parentheses. It's just take out what's in common. Always look for what's in common first. All right, now what? Well, now it's the same. We have 2 things. We got the A alone. That is its own thing times the A minus 7 equaling 0. So what does that mean? The first one alone could be 0, or the second one could be 0. So the first one's done. There's nothing more to do with that. A itself could be 0. Or how do we finish the second one? Add 7 to both sides. A is 7. So the answers are 0, 7. Either one. Does that make sense? So this time it was A alone. One of the items was just A. And the other was A minus 7. Remember we said each one equal to their own 0. And solve. Is that good? Questions on that? Hey, are those answers right?
So you would
Yeah.
so when you get to that second step, you would just multiply on the inside to make that A equal 0?
Well, A by itself is going to equal 0.
So what's your question?
Because you can't do the 2 parentheses after that step, correct?
Right, because well, it's not needed. Everything is just first power at this point. Yeah, so I took out an A because they both had an A. So that's always first. Before we ever think about two parentheses, we should ask, is there something in common? That's always the first question. And there is. They both have an a. So then I put it in the front, and then I just ask myself, what would work? A times what would go back to a squared? Well, a. And a times what? Minus 7. That's how I came up with those. And then, yeah, I don't do the two parentheses, because this is just first power. If this was like second power or something, I might think about going further. But it's just a regular a. So, yeah, I'm done factoring. I'm ready to set each one equal to their own 0. That makes sense on that? By the way, are those answers really true?
Yes, because it would set the
Yeah.
equation.
Let's put in a is 0. If we're saying a can be 0, right? We say a can be 0 or a can be 7. Is that true? If you put in 0 for a, does it make the equation true? Is 0 squared minus 7 times 0 equal to 0? Well, yeah, it's like obvious, huh? Yeah, that we should have seen that one coming. All right. And what about the 7? Is that right? Is 7 squared minus 7 times 7 equal to 0? 7 squared is 49. 7 times 7 is 49. Yep. See how both those make it true? That's what we're finding. The numbers that make the thing true. All right. Okay. So b squared equals 25. Let me give you some formal steps now, which I think will help. So when you have x squared or any letter squared and an equal sign, that's the new deal, right? We have the equal 0 stuff. Here's the steps. Step 1, get a 0 on one side. So you see what I'm talking about? On this problem, they don't have the 0 yet. So we got to get the 0. Right? So the first step on this problem is to subtract 25 from both sides to get a 0 over there. Everybody with me? That's step 1. You've got, if they don't have a 0 for you, you've got to get a 0 over there. Are we good? Subtract 25 from both sides. Get a 0 over there. Step 2, then factor. You know, like the parentheses. And then step 3, each equals 0. So step 1, get a 0. So I've got a 0 over there. That's step 1. Step 2, factor. Now how am I going to factor that one?
B and B and B times B.
Yeah. Remember, it's just an FL. It doesn't have a middle term. Oh, by the way, maybe I should ask, do they have something in common? No. B squared and 20, they don't both have a B, do they?
Well, they have square roots.
Yeah, but that's not a same piece. Yeah, we're going to do a similar action. That's different than having the same piece. They don't both have a B, they don't both have a 5. There's nothing they share in common. Right? Does that make sense? So, because the last problem, they both had an A, right? So we did that first. But this time, they do not both have a B or a 5 or anything. So instead, we just go, yeah, FL.
Negative 25 doesn't have a square root.
It's rootable. 25 is rootable, yeah. So we just say front times front, B times B, last times last, 5 times 5. And how do you get negative 25?
Plus 5 minus 5.
1 positive, 1 negative.
Yes.
Good, remember that?
Yeah.
Hey, what if it had been b squared plus 25 in the middle?
Plus 5 plus 5.
Would be plus 5 plus 5?
Yeah.
No, you should know better than that. I beat that drum last week. Boom, boom, boom. Don't you remember? Plus FL can't be done. Only minus FL. You guys never forget anything I say, right? You guys play these videos on YouTube over again on the weekends, right? No? All right, yeah, no, I know it's a tricky rule. That's why I bring it up. Remember, if you have plus FL, that can't be done. So only minus FL can be done. I know you think it would be plus plus, it's not. Anyway, enough said. Let's go on from there. Can I just say, hey, the answers are negative 5 and positive 5? It's just going to be opposite, opposite. So there we go. So type in negative 5 and positive 5. We good? So here's the 3 steps. Everybody got those copied down? There's the 3 steps that you want to follow when? Like, what is the category? You know, that's what hard math is. Everything starts to look alike. It's when you have x squared with equal signs. When you have x squared or any letter squared with equal sign, you get a 0, factor, and then each one equals 0. That's always the game plan. All right. All right, try that one. I'm going to make that an X because I don't like S's. My S's look like 5s. So try that one. So remember, what are the 3 steps for x squared with an equal sign? Step 1, get a 0. Well, it's already got a 0. So we don't have to do that. It's nice. Step 2, factor with the parentheses. Step 3, each one gets their own 0. If you can do that. So step 1, get a 0, already done, don't need that. Step 2, factor. So that's the 2 parentheses, right? Because they don't have anything in common, do they? 4x squared has nothing in common with 1, so I'm not going to do the 1 parenthesis step. Am I making any sense when I say all that? Remember, the first question is always, what do they both have in common? Usually the answer is nothing. But if they do have something like they both have an x or they both have a number, then you got to do the 1 parenthesis step, huh? But usually they have nothing in common, like this one. And we go right onto the 2 parentheses, which is what we do here. Right onto the 2, it's an FL. Notice it has minus in the middle. They're never going to give you FL plus in this situation. Front times front to be front.
2 and 2.
2x, 2x. Last times last to be 1. 1 and 1. 1 times 1 is 1, huh? What signs do you need to make negative 1?
Positive and negative.
1 positive, 1 negative. Good. 2 there. And then set each one equal to their own 0, right? Step 3. Here's step 2. Each one gets their own 0 because they're multiplying to be 0. So either one could be 0. And then you got to solve. Got to solve each one separately, huh? Right? This one's a little more work. We can't just say, we have to actually solve it out because it's got 2 parts. You know, you might be able to do it just by looking at it, but if you need to do the steps, go ahead and do it. So negative a half, yeah, because we need to divide, exactly. Good, negative a half. The other one, add 1 to both sides and divide. Positive. So it's negative a half and positive a half, huh? Good. Questions I can answer? All right. All right, try that one. Let me write it up here for it. 4w squared is 7w. All right, so there, whenever you see x squared or any letter squared with an equals, what's step 1? Get a 0, yeah. Yeah, so remember, whenever you see x squared or w squared or whatever with an equal sign, that's what's new today, equal sign, get a 0. That's just got to be your first step, get a 0. And then step 2 is factor, you know, with the parentheses, and step 3, each one equals 0. So there's our 3-step method. Get a 0.
There's 2 answers to this one, right?
Right.
0 and 7.
Okay, yeah, so step 1 is get a 0. So that means I'm just going to, can I just jump it to the other side, right? Whenever something just jumps to the other side, it changes the sign in the front of it, huh? It's the same effect as subtracting 7w from both sides. So jump it over, you got a 0. Is that good? Get a 0 like that. And then factor out the w, because they have a w in common. Everybody see why I did the 1 parenthesis instead of the 2?
Yeah, W.
Because they had w in common.
And then when you have a variable by itself, you set it equals 0.
Right. That's right. Everybody, so there's step 1, get a 0. There's step 2, factor. Now step 3, each part, including the variable by itself, gets a 0. That making sense? So this one's done. Nothing more to do there. The other one, I got to add the 7, divide by 4, boom. 0 and 7/4 are the two answers. Is that good? Is that reasonable? Question, comment?
If we type it in like that, or if we type in 1 and 3/4, it'd be the same thing.
Oh, yeah, they don't want mixed numbers. Yeah, they'll tell you in the blue they don't want mixed numbers now, so got to be 7/4. Good on that? Questions I can answer? All right. It's a little harder factoring now. Okay, so we have 20x squared minus 16x equals 48. All right, you know the game plan. You see x squared with an equal sign. What do we do? Get a 0. First off, get a 0, then factor.
Well, that kind of makes it easier, because then it goes into the 2 parentheses if you get the 0 first. Because it's a 3-term.
Right, but first remember, ask what's in common. This one's going to have something in common. You're going to do the 1 parenthesis first, then do the 2.
Oh, okay. Then it would.
Right, so step 1, jump this over. So x squared with an equal sign, step 1, get a 0. Right, so we get 20x squared minus 16x minus 48 equals 0. So there's step 1, we got our 0. Right, step 2, factor. Now, what's the first step in factoring that thing? Look at them and say, what's in common? What do they all have? 4, right? Doesn't 4 go into all of them? Use your calculator. Divide them all by 4 and find the new inside numbers. So what goes on the inside? 4 times 5x squared, 4 times 4x, and 4 times 12, huh? Good to there? So do that first. Now go on to the 2 parentheses. So this is a little harder, this kind of factoring. Remember this kind? You're thinking about FOIL, right? F-O-I-L. Multiply to be the back, add to be the middle. Remember that? That was the harder kind. See if you can get that. Front times the front to be 5x squared. What times what is 5x squared? 5x and x. 5x and 1x, in other words, right? Because remember, we're talking about multiply, not add. Don't do 1 and 4. We're not adding. 1 add 4 would be 5, but we're not adding. We're multiplying. What times what? What times what? Remember, it's all multiplied until the very, very end when we add the middle. That's the only add. Everything else takes multiply, multiply, multiply. So what times what? 5x times x. Right?
Negative 6 and positive 2.
Why not 3 and 4?
Okay, it won't give you the OE.
Won't work, huh?
So 6 and
Oh, you're right. You are right. Yeah, I would first try 3 and 4, because right, so we got front times front making front, 5x times x makes 5x squared. Now we need last times last to make 12. Don't worry about the signs. We do that, the minus 12. We do the signs at the end. I would right away try 3 times 4 instead of 2 times 6, but 3 times 4 doesn't work, does it? How do you know? We'll just try the oi, right? 3 times 4 makes 12, but the oi, the middle oi, the 2 inner, oi stands for inner, inner, 3x, outer, outer, 5 times 4 is 20x. Can 3 and 20 somehow make the middle minus 4? No way. 3 and 20 makes 23, or if you subtract them, it's 17. It's not even in the ballpark of negative 4x. No way. Well, okay, but try switching the order. You know, sometimes that works. It won't help here, but sometimes it does. Switch the order. Try again, right? Now, what the 2 inner make 4x, the 2 outer make 15x, 3 times 5. Can they make minus 4x? Again, no way. So now you got to go to the 2 and the 6. Everybody see how I tried 3 and 4 in both orders and nothing's working? For the oi, it's all about the middle, getting that oi to work, right? Everybody see what I'm doing? Remember that? The inner, inner, outer, outer. So now you go, okay, instead of 4, 3, let's try 2, 6. I'm going to do it wrong at first again. Kind of showing you worst case scenario here. 2x, 2 inner, 2 outer, 2x and 30x. Can they make negative 4? No way. Switch the order. 6 here, 2 there. Is that going to do it?
Yeah.
There she is. The 2 inner makes, whoops, I'm kind of scribbly here. The 2 inner makes 6x, the 2 outer makes 10x. Can they make negative 4x? Yeah. Plus on the 6, minus on the 10, right? 6 minus 10, right? You gain $6, you lose $10, you lost 4. They add to be the middle, don't they? So that's my right combo. Everybody see how I found that? How do the signs go into the parentheses then? Well, the plus is on the 6 right there, huh? Okay, this one always goes straight up. The bottom one always goes to the back. Okay, yeah, but we're not. Normally we're done here. Normally we stop and we're like, whew, got it, done. But when you have the equal 0, that's what's new today. Equal 0, you got to keep on going, huh? We have to do another step. What do we do? What's step 3? We did step 2, factor. Step 3 is each one gets its own 0. Now, let me, right? Going to set each part of 0? It doesn't. That's the crucial question. So let me expand on that. I try to not give you too much information at once. Each part that has a letter, only the parts that have letters. So forget about the 4. If that was 4x, I would set it equal to 0. But if it's just a 4, 4 can't be 0. You guys understand the difference? Right? If that had an x, if that was 4x, then I would say, yeah, 4x could be 0. How could 4x be 0 if x is 0? Right? But if you don't have a letter, if you don't have a variable, you can't change. Right? So if it's just a number without a letter, skip it. 4 can't be 0. I mean, you could write that if you want. 4 is 0. No, it's not. Right? 4x could be 0, but 4 can't be 0. So there'd be no point. Don't even bother to write that. Right? But the other two parts, 5x plus 6 is 0, x minus 2 is 0. Solve both of them. So subtract 6. 5x is negative 6. Divide by 5. Yep, negative 6 fifths. Add the 2. Or 2. The answers are 2 and negative 6 fifths.
So what happens to the 4?
Nothing. I just leave it out. Now, if that seems weird, like, can you just do that? Think with me logically, guys. If I said, hey, 4 times some number in my head times some number in my head is 0. Just think reasonable. Just set aside all this fancy formula stuff for a minute. If I just said, hey, real life, 4 times something in my head that I'm not telling you is coming out 0. I'm multiplying 4 with 2 other numbers, it's coming out 0. What does that mean?
You don't have enough information.
That means one of my numbers has got to be 0. How else can I multiply those things and get an answer of 0? Somebody's got to be 0. And it ain't the 4. He's like, I'm 4. Don't question me. I'm not 0. I'm 4. Right? So you see the logic? 4 and something is 0. Well, one of those somethings is 0. That's all it means. It means nothing about the 4, does it? That could be a 7 in the front. Who cares? It just means one of those other things is 0. That's reasonable, isn't it? Everybody see why the 4 has nothing to do with the logic? Right? I'm expecting like lots of nodding, like that makes perfect sense, Mr. Heron. But or shake me off, say no, that makes no sense, then I'll know to talk more about it. No? No sense? Question?
So if you actually multiply the 4 by that and then like solve it, you get the same thing.
Yeah, it'll work out. Yep, it's true. You did it? Yeah, that's right. Yeah, one more time. Let me try one more time. Just think, guys. If I said 4 times something, right? 4 times something is coming out equal to 0. What does that mean? Doesn't that mean this guy could be 0? Or, this could be whatever, some number. 4 times 0 would be 0 times anything is 0. Right? Or the back guy could be 0. Because 4 times anything times 0 would be 0. Right? Doesn't it mean one of those two numbers has got to be 0? How else can you multiply 3 things and get 0? Somebody's got to be 0. Do you see how the 4 has nothing to do with the thing to me? This could be an 8 for all I care. Would that change my conclusion in any way?
No, it's still gonna be 0.
Still means one of these two numbers is 0. It has nothing to do with what that number in the front is, right? See how that's irrelevant to the process. Right? So numbers in the front just drop them. If they don't have a letter, they're unimportant. They can't make anybody 0. All right, so there we go. So we got B parenthesis 12B plus 5 is 7. First thing to do on this, guys and gals, is just to distribute. Just multiply through there. Get 12B squared plus 5B is 7. That makes sense what I did there? Just distribute through there. Oh, wait a minute. It's not on the screen. There we go. Funny, it just wigs out every now and then. There it is. It's like magic. All right, so there it is. I just distributed that B from the outside. And now, do the normal thing. What's the first step now? When you got x squared with an equals, what's step number 1? Get a 0. Don't forget that 0. So step 1 is subtract the 7 from both sides, right? 12b squared plus 5b minus 7 is 0. Good. Step 2, factor with the parentheses. Right? Why did I put an x in there? Where'd that x come from? Came out of my mind and it's wrong. Try the 2 parentheses now. Do the FOIL thing. You don't want to try.
No, I don't like that 7.
7's nice.
No, I
He's
don't like it.
he's a prime, so it's got to be 1 times 7. There's no other choices. Prime numbers are nice. There's no other choices. It's only one way to break it down. No, prime means only one way to break it down. It's 1 times 7. It's got it. Right? What's hard is numbers like 12. There's a lot of options. 3, 4, 2, 6. Who knows?
What was the addition of that prime?
Oh, this is a tricky one. Yeah, this is a hard one. I see it, but it's because I do a billion of these. It's not going to be 4b and 3b.
It's going to be 6 and 2. No, it's not going to be 6 and 2.
Doesn't work there either.
12 and 1.
It is. Yeah. Yeah.
Why?
Because 12 minus 7 is 5. Yeah. This just take practice. You just have to do a zillion of these. Yeah, if you thought it was 4 and 3 at first, that's reasonable. That's what you should try first. It just doesn't work. If you put the 1 and the 7, it won't make the middle. Either way you do it. Here, I'll write it out. I just don't want to waste too much time on this, but I know this can be frustrating for students in your homework, so I want to show you. So if you did 4 and 3, which is reasonable, you should try to start with 4 and 3 for the FOIL thing, FOIL. And then what are you going to do to make 7 at the back? 1 times 7, right?
Right.
Or 7, 1. If you do the 2 inner, 2 outer, it's just not going to work at all. 3b, 1 times 3b is 3b. 4 times 7 is 28b. 3 and 28, how's that going to make plus 5b in the middle? No way. So then switch the order. Put the 7 here, the 1 there. It's still not going to work at all. Because now you're going to have, with the 2 inner, 21b, and the two outer are 4b. Can 21 and 4 make 5? No way. So we're done with 3 and 4. 3 and 4 did not work with 7 and 1 or 1 and 7. So now you got to go, okay, maybe it's 6b, 2b. It's not. It's not going to work with either order on that. Put 7 and 1. See if that works. It won't. That'll be 14b for the two inner and 6b for the two outer. Can 6 and 14 make 5? No, they make 20 when you add them. And so that didn't work. We'll try switching the 7 and the 1. See, I'm just trying every combination. I'm switching the 7 and the 1. What was it? It was so 1 here, 7 here now. 1 here, 7 here. Now try the two inner. It's 2b and the two outer are 42b. No, we're just getting worse. So it's not 6 and 2. It wasn't 3 and 4. What else makes 12 other than 3 times 4 and 2 times 6? 12b and regular b. This will work. This is it. Right? Let's try it. Not the order I have it here. It's going to be the other order. The two inner makes 1b. The two outer makes 84b. 7 times 12. No way. That's not it. Switch it. It's our last chance, and it'll work. The two inner make 7b. The two outer make 12b. Can 7 and 12 make 5? Kind of sloppy. 2 inner 7b, 12b. Yeah. Sign in is on the bigger. Minus 7 plus 12 makes plus 5. So that was a hard one. Put the minus on the 7. The plus goes to the back. All right. See, that is just hard factoring. It's rare that it's 12b and b like that. All right. So each one equals 0 separately. So 12b minus 7 gets its own 0. I am running out of room on this problem. This problem is using up all of our minutes. All right. Move the 7 over. 12b is 7 divided by 12. Move the 1 over. B is minus 1. 7/12 and minus 1. Got them. After a lot of work. Is that okay? Just take a little time, a little practice. All right, w squared minus 2w is 4d plus 4w. So you got x squared with an equals, or w squared. Step 1 is to do what? Get a 0. So you know what you need to do. Make that right side become 0, right? Get a 0 on the right side. So that means you're going to subtract 40 and subtract 4w.
But you can combine like terms there.
Good job. So combine w with w, right?
Yeah.
So that'll put a 0 over there. And that'll make w squared minus 6w minus 1. Put them in the right order, right? From highest power to lowest. We all good with that? So we get w squared minus 6w minus 40. Because the 2w and the 4w make 6w. What happened there? That makes sense. And now do the right. Just factor with the parentheses and take it from there. So factor, see if you can get it from there. All right, so it's the FOIL thing, the multiply, add, right, 2 parentheses. What? So W times W. What multiplies to be 40? 4 times 10, huh? And sign in the middle? It's on the bigger. It's on the 10. Right? Plus 4 minus. If you gain $4 and lose 10, you lost 6. That makes the middle. So then, you know, it's just negative 4, positive 10. Done. Good? Ready for the word problems? We'll do what we can. The length of the top of a table is 5 meters greater than the width. The area is 66 square meters. Find the dimensions of the table. Well, I assume the table's a rectangle. They're not saying that, but I assume that's what they mean. So we'll make it a rectangular table. All right, so they're talking about the area of a rectangle. Does anybody know what's the formula for the area?
Length times width.
Yeah, that's right. Length times width. Exactly. Remember that?
But
Area of a
it's
rectangle?
gonna be meters squared, isn't it?
Yeah, areas in square meters, because it's meters times meters. Which is meters squared, like x times x is x squared. Yeah, we treat units just like we do letters. Good there. So that means what then? That means, okay, the area is 66. So put in, so 66 equals length times width. Good so far? Am I racing ahead of you? So as soon as we read area of a rectangle, we write area equals length times width. So 60, and they tell me the area is 66. You don't need to do anything with the square meters, by the way. It is square meters, but you don't have to plug it in or square anything or anything. That's just the units. Don't need to touch them. So just 66 equals L times W. Now, what am I going to do with the L and the W? This is kind of weird. We have 2 letters. 2 letters.
Well,
We don't want 2 letters. We want 1 letter, huh? Remember what we learned earlier when we did word problems. What do we always do when we have 2 slots, 2 letters, 2 whatevers? You know, you let one of them be simple X. Remember? Doesn't matter which one. L, W, whatever. Let one of them just be X. And then let the other one,
X plus 5.
some kind of X formula. Yeah, X plus 3, X minus 2, something like that. How do you know? But what do they say? 5 greater. 5 greater is X plus 5. Exactly. So you just let one of these be X, and you let the other be X plus 5. Does that make sense? That's how these word problems will always flow. If you get the hang of that flow, you can whip out these word problems. Does that make sense? You write the basic formula, areas, length times width. You put that in your 3x5 card. But you need to memorize it, right, for the next exam. And then you have 2 slots, L and W. One of them's X, always. Every word problem. Somebody is just simple X. And the other guy is an X formula. And how do you know what formula? Whatever they say. If they say greater, that means add. X plus 5, huh? What if they said, you know, the top is 3 shorter? What would I do for 3 shorter? Would shorter be add? It'd be subtract, wouldn't it? 3 shorter would be X minus 3, right? That makes sense? All right, so now I've got this equation. How do I solve it? To zoom and a zoom. X squared plus 5x. You guys with me? We good to there? Now what? X squared has reared its ugly head. Right? When x squared shows up in the middle of a word problem, like a sea monster in the middle of the ocean, reared its ugly head, when x squared shows up on the scene, what do? Get a 0. It's got to be a knee-jerk reaction. That's why I wrote those 3 steps, and we did them and did them and did them and did them. Hope that's sinking deeper and deeper. Because it'll happen all the time in the rest of the course. This last, what do we have? This is early March, April, May. We have 2 more months of the course. In the last 2 months, we'll be doing all kinds of stuff, and out of nowhere, x squared will show up. And you just got to know what to do. It's got to be like a knee-jerk reaction. Somebody wakes you up in the middle of the night. X squared with an equal sign. Get a 0. Get a 0. You just got to know it. Because you can't delay at this point. You can't be thrown off and look back through your notes. You waste your life. Right? We have a ton of these at this point. X squared with an equals, get a 0. Just automatically first step. Now, where do I get the 0? I mean, left side, right side? Well, you know what's easiest? It could be either side. What's easiest is to leave x squared on the side where he will be positive. Because it's a pain if he has a negative in front of him. If I jump that x squared over here, he would become negative x squared, right? When things jump, they change their sign. I don't want to do that. So just make the 66 do the jump. And just get the 0 on the left side. That's fine. That's easier.
I'm still confused on how you got X from the X.
Yeah, so you had two items, L and W, from the formula. With me there so far? That's just from the formula. One of them, the first one, will always just be simple x. Every time, every word problem. Almost.
So that's the length?
Yeah, but you could have let it be the width. It doesn't matter.
Okay.
You just let one of them be x. So it just means it's a variable. It could be anything. We don't know what it is yet. So you just let the first one be x every time. And the second one will be some kind of an x formula. So this one's x. The second one's x. Now, how do you know what the formula? Well, they said, whoops, I just squished it. They said greater. 5 meters greater. So greater means add. So x plus 5. So one will always be x. The other will be an x formula. All right, so move this 66. Jump it over here. Becomes a minus 66, right? When things jump to the other side, they change their sign. And now you know what to do, right? We got a factor, right? You guys are pros at this. Now, what multiplies to be 66, adds to be 5. You guys have your calculator? What times was 66?
11 and 6.
Oh, yeah, 6 times 11, huh? How do the signs go?
-6 positive.
Sign in the middle goes on the
Bigger.
bigger. Plus 11 minus 6, right? You gain $11 and lose 6, you gain 5. Okay, now what does that mean about the answers, though? X equals opposite, opposite, right? Opposite of minus 6 is plus 6. Opposite of plus 11 is minus 11, right? Remember how it's opposite? Because you said each one equal to 0. Can I just skip that? Is that okay? You said each one equal to 0. It's going to be opposite, right? We good to there? How are we doing? I hope I'm nervous. I'm just talking to myself up here. Right? We good? You with me? Nod yes or nod no, please. And I know to speed up, slow down, do more, do less. Questions? Does this make sense? So I just factor, right? What times what is 66? 6 times 11. And how do the signs go? Whatever sign is in the middle goes in the bigger.
Plug it in.
Right? And then it's just opposite, opposite. Right? Okay, now, what if I was to measure this tabletop? What if I was going, hey, I got a tape measure. I'm going to measure this tabletop. Are you ready? I got an answer. It's -7.
Oh, that's hard.
Can that be? Can I measure this and say it's -4 feet?
No.
No. Widths and lengths can't be negative. Well, then what's with this negative answer here? They're telling me the width or the length or something is -11? Baloney. No way. Right? Throw that away. Now, why did math give me that answer?
Because it's math.
Maths.
Because math isn't real. Right? This isn't news to you, is it? Is this news to you?
Not tangible.
Right? What?
The
Right? Is
answer's
this news to
gonna
you?
be the positive number, it's gonna be the positive number plus 5. So
Yes.
it's gonna be positive 11.
Yes. Exactly.
They can't be.
When I say math isn't real, math, and that's true. Math isn't real, right? What if I said, hey, on the way to class today, I saw 3. There it was. 3. You guys, what do you mean, Mr. Herring? You saw 3 people or 3 cars or? No, I didn't see 3 people or cars or 3 objects. I just saw 3. You know, you go, what do you mean? You saw like the number 3 spray painted on the wall? I mean, what do you mean? I go, no, I didn't see the number 3 written anywhere or 3 objects. I just saw 3. You would know I was ready for the padded room, huh? Right? 3 itself isn't something you can taste, touch, or smell. Right? Math isn't real. It's just in your head. Well, I'm really not supposed to let that secret out. I mean, what are we even doing here? Class is over, right? I mean, math is not real. It's just in your head. What are we doing here? It's true. Math is not real. It's just in your head. But it's used to describe things that are real. Right? If I saw 3 cars at Blackstone and McKinley, a real place, 3 real cars in a head-on collision, I came to class and said, I saw 3 cars out there all headlong collided at Blackstone and McKinley. You know the concept of 3ness. It's in your head. It's in my head. So we can talk about things that are real. So math itself is not real. But it's used It's made up. We just made up math. We made up numbers. We just made it up to describe things that are real. Right? Okay. Well, that's the point of this crazy negative answer. Math doesn't know about our real world. It doesn't know that in the universe we live in, you can't have negative widths. Maybe some other weird universe, but not ours. So math is just running numbers. It's just going, hey, them numbers work. That's all I'm telling you. There's a negative number that works. And we're like, thanks, math, but we're in a real life problem here where the width can't be negative. So we just throw that away. We know better. We got to keep 1 foot in reality when you're doing word problems and 1 foot in math, right? Throw away the negative answer, and it's exactly what you were saying. One of the answers is 6. How then do you find the other answer? You go back to the real life words. What does it say? 5 greater. What's 5 greater? The length of the tabletop is 5 greater. Length is 5 greater. 5 greater than what? Than 6. 5 added to 6. So positive 11 is the what? The length. Well, then what does the 6 got to be? If the length is 11, what is the 6? It's got to be the width, doesn't it? It's all their only other choice.
Yes, sir.
There's the 2 real life positive answers. Does that make sense how I wrap that at the end? Does that make sense? Throw away the negative and then go back to the words. Length, 5 more. Add 5. 11. Length, 11. Because you got to know which is which. They're going to ask you for width and length. You got to know which is which. How do you know? The words tell you. Length is the greater one. The length is the 11. Now, having said all that, we don't have forever to do these problems. If you want to speed up and save yourself a little bit of time, when you get the positive and the negative answer, you know that negative is going to end up being the other positive. So just cut through it and say, look, it's going to be 6 and 11. You just know that's the answer. How do you know which is which, though? You still got to read the words. The length is the greater, so you know the 11 is the length. Make sense? All right. They're not in a nice mood, I guess. All right. Try that one. So we're talking rectangle area again. Same formula as last time, right? Same formula as last time. Area equals L times W.
1/2 times B times.
That's for triangle. That's the next problem.
Oh.
That's triangle, because triangle is half of a rectangle.
Where did I get triangle out of that?
That'll be number 3.
So I just tried it.
All right, so there's your formula. Area is length times width.
Isn't that 9? No, wait, it's 5 times 5.
Okay, area is 245. Don't worry about square feet, whatever. We don't have to do anything with that. Area is just, I just want the numbers. 245. All right, area is 245. Good there?
Time is long.
Now, what are we going to do? I hope it's clear for everybody. What do we have? 2 players in the game, right? L and W. What? And we're always in the next problem of the triangles. We're going to have base and height, B and H. Who cares? They're just 2 names. Call them Joe and Tom. Who cares? They're just 2 names. What do we always do with those 2 names we have? One of them, the first one is always what? Plain, simple, X. Right? Make the first one plain, simple, X. And what's the second one? Some kind of an X formula.
Don't make noise.
X plus 3, X minus 2, 4 times X,
It's cheated.
whatever the words are saying.
Second time.
What are the words saying? You guys tracking with me? The first one's X, always. Everybody hear me on that? Always, right? The first one is just X. Don't stress out about it. It's just X. Just let the first one be. And the second one is always just like an X formula. Like X plus 2, X minus 3, 7 times X. How do you know what formula? Well, they'll tell you in the words. What do they say?
X high 5.
5 times. Is that X plus 5?
No, time 5.
Yeah, times 5 doesn't mean add 5. It means multiply by 5, doesn't it? So it's 5 times X. Everybody see the difference? In the last problem, they said more. Didn't they say more? Something more, 3 more, 7 more, whatever it was. So that was add. They say more or bigger, that's add, isn't it? Right?
I'm going again.
If I say, Johnny's age is more,
Yeah.
then you add, right? If they say less, you subtract. But if they say times, it's times.
Probably next week.
Good on that? Everybody see how we get the second formula? More is add, less is subtract, times is times. All right. Excuse me. Okay, now this is x times 5x, which is 5x squared, actually. A little bit different, huh? Does that make sense? To there? What are we going to do now?
Get a 0.
What do we always do? X squared, it's reared its ugly head.
I do it differently,
X squared
guys.
minus
Never heard of that.
2.5.
Did the root method?
No, I draw a picture.
Ooh,
Oh,
everything
I
missed.
draw a picture, 4x plus 10 equals 245.
So the x squared rears its ugly head. What do we do? The sea monster. We get. I'm doing all I can to help this stay in your long-term memory, with weird sound effects and everything. No extra charge. Sound effects included. I remember years ago, my youngest daughter, 10-year-old Abigail, she's very, very high sensitive to things. Anyway, she's hyper. She's just real hyper. She's a fabulous soccer player because she's fast and hyper. Anyway, but she's also very sensitive. We went to one of these 3D theaters. It was like 5 years ago. She's probably 5 years old. And in San Diego, we're on vacation. And went to this theater where they make it all 3D and stuff like that, you know. And anyways, and we told Abigail, it's going to be okay, honey. It's just pictures on the screen. It's just pictures on the screen. It looks like it looks real, yeah. And we get in there, and she's like half freaky, but she's making it through like the 3D thing. And I didn't realize they made it 4D. They put little things under your seats that when you go through one of the scenes, it like brushes the back of your feet. She just went through the roof. You know, I didn't realize that was coming. You know, and all of a sudden, it hit her back of her feet. Ah! Crazy, running out of the theater. Why did I tell that whole story? What were we talking about? I had a reason.
Zeros.
What's that?
We're getting zeros.
What does that have to do with Abigail freaking out? I had a reason. I don't know. Whatever.
You gotta freak out.
Yeah, I guess I freaked out. I don't know. All right, anyway, get a 0. Oh, when the sea monster shows up all of a sudden. I don't know. Get a 0. You just got to know it.
Special effects for free.
I was talking about special effects, so that's what there was a reason, but I lost my reason. Yeah, get a 0. So jump this over, get a 0. I'm giving you these special effects. It's 3D with sounds and everything. All right. So how do we factor that thing? What do we do? Well, what's the first step on every factoring problem?
They have in common.
What do they have in common? You got to get that 5 out of the way. Divide this thing by 5. What is that?
49.
49. Good. And then, what do you do with x squared minus 49? 2 parentheses. 7, 7, 1 plus 1 minus. And so, now remember, the 5, who cares? He doesn't have an x. Remember, you ignore the parts that don't have x's. So the answer is plus 7 or minus 7. You know the minus 7 is bogus. In the universe we live in, you can't have a width or length that's negative. So the answers are both 7. Both length and width are 7. Oh no, that's not true. I'm making stuff up, and it's not true. One of them is 7. How do you always get the other answer?
5 times.
From the words. Yeah, what do the words say? 5 times. What is it? 5 times as long. So the length is 5 times 7, 35. So that's the length. This must be the width.
Wait, what did
Yeah. So yeah, the trick is at the very end of a word problem. After you've got one answer, plus I throw away the negative, we don't care about that. After you've got one answer, the way to get the other is the words. At the end of a word problem, you go back to the words. They'll tell you. What is it saying? 5 times as long. So you take that answer of 7 and you go times 5, 35. And that's the length. 5 times as long. That's the length. So then this 7 must be the width. Does that make sense? So the end of a word problem is always given to you by the words. By the words. They'll tell you. They won't beat around the bush.
5 times 7 because it's at 5 times as long.
Yes. 5 times as long. So I took that answer and I went times 5. That's what we'll always do. If they said 3 more, I would have taken that answer and added 3. Does that make sense? It's whatever they are saying. If it's more, it's add, less subtract, times it's times, to get that answer. And you know that's length because they said 5 times as long. So that's length. The other one must be width. Question?
Does it add up to 245?
Yeah, if you multiply this in your calculator, it's 245. Length times width. Okay. All right, so let me just give you the area of a triangle. Do you know it? Some of you already know it. What's the area of a triangle now? Triangle, if you take a rectangle and you cut it in half, that's what a triangle is. It's half of a rectangle, isn't it? So it's half. Base times height. You can call it length and width again if you want. Doesn't matter. Whatever you call the two things. Base and height, length and width. You know, Joe and Tom, like I always say. Whatever. It doesn't matter. So the area, so for triangle, because a triangle is half of a rectangle, isn't it? So half of base and height. Okay. Now, what's the area? 60. Don't worry about the units, just the numbers. All right, now, what am I going to do for my two slots? See how we have two slots again? See how it's always the same game on these word problems? Two slots. Now, normally I'd let one of them be X, the other be an X formula, but they're giving me the two formulas right here in this picture. See the picture? One of them is an H, one of them is an H plus 7. So just use what they're giving you. I don't have to do anything on my own. Does that make sense? Just use H and H plus 7 because they're giving them to you. Good to there. So for a triangle, the area is half the base times height. Put in the base and the height. Good. Now, how am I going to solve that equation? Yeah, we got to get a 0. But first off, you know what I got to do? That half is a pain. I don't want fractions in there. They always cause trouble. Do what's that?
Distribute.
You can make it a decimal, but decimals are painful too. I just want it out of there. What can I do to get rid of that half? Get rid of the half by multiply by 2. Yeah, just multiply both sides by 2. That's the thing. Now, so I'm going to go this side by 2, this side, and it just cancels that out. This is 120. The other side, I'm just going to distribute the H. And the half is gone. Everybody see what happened there? So when you have the half in the triangle area formula, just multiply both sides by 2 to get rid of that half. It's just gone. See what happened? Oh, on the right side, the 2 and the half canceled, so they both vanished. On the other side, it didn't cancel, so it multiplied. Right? Is that good? Or you could say half of 2 is 1. It just made 1 on the right side. So that's why it's not important anymore. On the other side, 2 times 60 is 120. Okay. Can you solve it from there? We good to there? What do we do to solve? What are we going to do? What do we do when we see this? This is the sea monster. He has reared his ugly head. There he is. What are we going to do? Yeah. Get a 0. Just got to be a knee-jerk reaction. When you see x squared or h squared, just get a 0. So grab that 120, jump it over. Be minus 120, right? Right, good. And then factor. Now that means you got to take your calculator and say, what multiplies to be 120 adds to be 7 in the middle? I have no idea. So take 120. I would just take the 120 and try dividing by different things in your calculator. Like 10 and 12. No, that's not it. 5 and 24. 15. What's 15? And 8. Oh, yeah, that's it. Good job. 15 and 8. Do you guys see what I'm doing there? Well, he told me so. That helps. But You just take the 120, you just try dividing by different things on your calculator until you get a pair of numbers that can make the 7. They have to add, or in this case, subtract, to be the 7 in the middle, right? Remember, the middle is about adding or subtracting. If you add a negative, that's subtraction, really. You with me? Am I going too fast?
The bigger number's gonna be constant, because the middle.
All right, let's try the shark's teeth problem. Triangles. What formula am I going to use? Yeah. Area of a triangle. Half base height. Right? Take it from there. Feel free to check with those around you. I'll give you a second. Okay, we ready? So area tells me it's 21, right? And what do we do with the B and the H? What do we always do with the Joe and the Tom, the two unknowns? What do we always do? The first one is always what? Just X. The second one is always some kind of X formula. And according, right? Everybody with me on that? I hope you're getting that main idea. That'll really help you on these word problems. You always have two things, B and H, length and width, Joe and Tom, what do you want to call them? The first one is just X.
So if they don't give you a base, just put
Just put
an X.
an X. That's it. I mean it. I mean it. I mean it. I mean it. Really? That first one is just X. Pretty much every time. So that first one be X. The second one? What's the second one always? Some kind of X formula, huh? Like X plus 3 or X minus 10. Or, well, how do you know if it's add or subtract or whatever? Well, do they say greater or less?
Longer.
More or less? What do they say?
Longer.
Longer, one longer. I don't care about the units, centimeters, whatever. One longer. One longer. So is that X add or is that X subtract? Longer. Add. That's X plus 1. Everybody with me? See how that's very predictable every time? First is X, the second is whatever they're saying. Greater, longer, that's add, less, smaller, subtract. Times would be times. All right, now, there's our equation. Now, what's the first thing we do? We got to do something about that half, right? Get rid of that half. Just right away, get that half out of there. What's going to get rid of that half? Yeah, times 2. Bye-bye half, right? And then distribute the X. Good to there. So I got rid of the half, multiply 2 on both sides, distribute the X. The half is gonzo. And now what do we do?
Gotta get a 0.
Yeah. X squared, it's rear to its ugly head. Bring the 42 over. Get a 0. Becomes a minus 42. Factor that thing. X and X, 6 times 7. Sign in the middle. Sign on the bigger. Really, who cares at this point? The answers are going to be 6 and 7, aren't they?
Yeah.
I mean, you might as well just save some time. You know, plus, minus, little 6 and 7.
You can't
We-
have negative answers.
We ended up, yeah, we know we're going to throw away the negative anyway and just save some time. At this point, you're even right here, you can probably go 42.
You don't.
It's going to be 6 and 7.
It's just lying.
It's math is not realizing that our universe can't have negative widths. Yeah, anyway, how do you know? Now, the only thing left to determine, they're saying one of these is height and one of these is base. You can't mix them up. You got to know which one's the 6 and which one's the 7. How do you know?
The height is what's in the long.
Beautiful. It's always the words. Remember, at the end of a word problem, always go back to words, and they'll tell you. They won't beat around the bush. They won't say, ha, 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 I'm not going to tell you. They'll say, height is longer. Height is longer. This is the height. This must be the base. Huh. That good? See how to save some time on that? As soon as you get to the factoring step, you go, oh, it's 6 and 7. I don't need to mess with this thing anymore. Which one's bigger? Oh, height is bigger. Height is 7. Is that good? Feel like you can do these? Okay. The product of page numbers on two facing pages of a book. If I have a book and I open it up, what if I take a book and I just open it up to facing pages, pages right next to each other? If this is page 83, what's this page? 84 or 82. It's one more, one less, right? That's just a fancy way. Facing pages, that's a way of saying x and x plus 1. That's all they're doing. One of them is one more than the other. That's what it means to be facing pages in a book. One of them is one after the other.
Couldn't you do that? 2x plus 1 equals 156?
No. It's notice here product. What does product mean? Multiply. So one of these times the other is 156. Yeah, that's what they're saying. So product means multiply. Multiply the x times the x plus 1. Why is it x and x plus 1? Because they're facing pages. One is one higher than the other. And remember what I told you? Always, one of them is what? X. Always. And the other one is an x formula.
So it'd be x to the second plus 1 equals 156.
Yeah, so then you distribute. X squared plus x is 156. X squared, sea monster. What are we going to do? Get a 0. Bump this 156 over. This time I'm moving the 156 this way. Get a 0. Use your calculator. You're looking for two numbers that multiply to be 56, add to be 1. Use your calculator. Start. Now, how do you get it? Let me let you try. You guys have your calculators with you?
Yeah.
Very valuable to get used to doing this. Don't say it out loud yet. Give everybody a chance. Take your calculator, take the 156, and start dividing by things, right? Remember, let's make sure you get the hang, because these will be in the homework. Take 156, and I don't know what to start with. Start with 5, 6, 7, 8, 9, 10. Just go, and every time, most of the time you'll get some crazy decimal, just skip it. Divide by 5, it's just some wacko number. Divide by 6. What's 156 divided by 6? What is it? 26?
26.
26, thank you. 20. So then, okay, could it be 6 and 26? No, it's got to make 1 in the middle. They've got to add, but they got to make 1 by adding or subtracting. Right? See how? Okay. What are consecutive?
One after.
In a row, right? If the baseball team wins consecutive World Series, that means in a row.
Like the pages in a book.
Right. One right after the other. Now, it's consecutive even. So that would be like 10 and 12. Or 68 and 70. It's even numbers in a row. Right? Consecutive even. Like weren't the Giants winning the World Series on consecutive even years for a while?
Yeah.
Plus 2x.
So the first one's always X. Always. Right? And what's the second one going to be?
X plus 2.
X plus 2. 2 higher. That's what you do for consecutive even. By the way, in some of these word problems, they'll say consecutive odd. It's the same thing. Because think about odd numbers. 7 and 9. 23 and 25. They're always separated by 2 as well. From odd number to odd number or even to even, the jump is always 2. Isn't it? That makes sense?
Yeah.
Because it's 2 higher.
Yes, sir.
To go to the next even number is 2 higher. That makes sense? So it's x and x plus 2. And it says the product, what does product mean?
Multiplication.
Multiply is 168. So distribute, x squared plus 2x is 168. X squared, there he is. Get a 0. Jump it over. Minus 168. You know what you do now, right? Calculator. Take that 168 and divide by, I don't know, 10, 11, 12, 13, 14.
12 and 14.
What is it, 12 and 14? I think you're right, 148. Yeah, that's it, 12 and 14. 12 and 14, we're done. Is that good? We good with that? So I want to make sure you get the main point. Consecutive, even, or odd, you just go up by 2. Right? All right. Section. I'm pretty sure. They're talking about a right triangle, and they're talking about hypotenuse and stuff. Do you know the formula? If you have a right triangle, and this side is A, and this is what B here, and C there. Put a right triangle. What is it? Exactly. A squared plus B squared. It's called the Pythagorean Theorem. I'm not going to quiz you on the name. But that's for any right triangle. For any right triangle, a squared plus b squared equals 2. So if you're reading a problem, they go blah 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 right triangle, you go, I know the formula. So by the way, notice we have 2 triangle formulas. Now we have area, half base height, and Pythagorean. Well, how do you know? Well, did they say area anywhere? They never said area.
Never.
They said right triangle. So that's how you know you want the Pythagorean. All right, here we go. One leg, these 2 sides are. Okay, so it's basically saying 36 foot wide, blah, blah, blah. I'm just going to cut through all their fancy talk. They're talking about a triangle, basically. I think. Yeah, because they say diagonal. See how they say diagonal? So basically there's a diagonal that's 85. And one of the other sides is 36. You can put it here, you can put it up here. Doesn't matter, whatever. And then they say, hey, find the other side, it's x. Is that okay, guys? I want to just save you time and effort here. That's basically what's going on in that problem. So they're saying North Avenue here is 36, right? And the diagonal is 85. Find the x. Yeah, there it is. There's your triangle, if that helps, on the little picture they gave. See what they're saying? Right, so basically it's a right triangle. Find x. So this is easy, a lot easier than the last one. Everybody see what I did? They said North Avenue is 36, 85-foot diagonal. Find how long Main Street is.
Long enough.
Find x. So, right triangle, what am I going to do? What formula am I going to use? A squared plus b squared is c squared, right? So plug those 3 numbers in. How do you know which one's going to be the c? You always want to get the c right. How do you know 36x or 85? Which one is the c in the a squared, b squared, c squared formula?
85. The longest.
The longest side is always the c. That may or may not be the x. Which side is longest?
85.
The 85. That's the diagonal, right? This is your c. And the a and the b, who cares? You can put them in any order you want. You with me? Right? So it doesn't matter whether you have the x first or second, but it matters that the c is the 85 on the right side. Everybody good with that? So solve that equation now. All right, put me on the calculator. What? It's way too big for me.
1296 or
Thank you. And what's 85 squared?
7,225.
225? 7225? Okay, yeah, let me give you a quick way to solve this. Everybody good so far?
You do?
Right? A squared plus B squared equals C squared. Remember, again, the C is always the longest side. Whether that's a number or a letter, it's always the longest, the diagonal side. All right, here's a trick. Subtract 1296 from both sides. Somebody have that. It's going to be 6,929.
29.
59.
59.
5,000?
I need it on the calculator. Somebody got it?
1296. Yeah.
What is it? 5929? Oh, it's 5929? Is that right? 5929?
Yeah.
5929, okay. And you know what you can do to turn that into X now?
Square root.
Yeah, the root button. You guys know about that? Get a calculator that has one.
77.
It's only $10, $12, Walmart. Get that, if you're going to buy one, get a Casio Natural Display. Those are beautiful. They'll do all kinds, same price as the others, like $13. They're great. Bookstore, Walmart, Target. Root it, and something, what is it, root of 5929?
77.
77. That's our answer. So notice I did a trick there. I didn't get the 0. That's because there was only x squared. There wasn't a regular x. You're in trouble. You need a root button. You got a root button on that thing. What's that? Yeah, come up after class. You're in trouble with the calculator.